Now that we've seen how to do chain rules and how to do combinations of chain rules, we can figure out how to take derivatives of exponential functions and logarithm functions with different bases. What I mean by that is that we've taken an exponential function with base e, and we know how to take the derivative of that. We've taken a log function with base e, that's our natural log, and we've taken a derivative of that. So we're going to use those things in order to figure out how to take derivatives of exponential functions with a different base, let's say base b, and log functions with a different base, let's say base b. Now we want b to be a positive number, and we don't want it to be 1 because then our exponential function and our log function are uninteresting. So we assume our base is positive and not 1. The whole key is to use some rules that we know about exponents and logs, and then to apply our chain rules or some other rules that we know. So let's start with the exponential function. The exponential function is written as b to the x. Again, our base here is above 0, so it's positive and not 1, or else this is uninteresting. It turns out you can rewrite b to the x as e times natural log of b times x. Let me show you how that's done. So take your e of x equals b to the x. And what we're going to do is we're going to rewrite b. It turns out if you take e to a certain power, specifically e to the natural log of b, this is just b because e and natural log will cancel each other out so long as b is above 0 and not 1. So this is just b here, and that whole thing can be raised to the power of x. So this is just b to the power of x, and we can rewrite that using the power to a power rule as e to the natural log of b multiplied times x. Now, no matter what natural log of b is, it's just a real number. So whatever b is, natural log of b is a real number. So this is just like e to the ax power, where a is a real number. And if you remember how to take a derivative of that, if I take a derivative of that, it's just e to that power multiplied times x, and then I have to multiply times the real number out front. In this case, you have to multiply times natural log of b. We just saw that e to the natural log of b to the x, that's the same thing as just b to the x. So if you want, you can rewrite this derivative as natural log of b multiplied times b to the x power. So if you have any other base other than e, you can take a derivative by taking that base to the x power times natural log of the base. So that's how it's done with bases of different numbers. So here it is again. Taking e to the x is bx means that the derivative is natural log of b times b to the x. By the way, if b is in fact e, natural log of e is just 1. So you just get back e to the x again. So this is consistent with the derivative rule that derivative of e to the x is e to the x. Now for logarithms with base b, if I want to take the derivative of that, what I can utilize is a rule of logarithms. This is what I call the change of base formula. If I want to take a logarithm base b of x, then I can take a log of any base, we'll use the natural log, of x divided by log of any base. Again, we'll use the natural log of b. So long as they're the same bases, we can do that. And then if I'm going to take a derivative, well, this is just the derivative of natural log of x divided by some constant. So this is just a constant 1 over natural log of b times natural log of x. And so derivative of natural log of x is simply 1 over x. So we take that constant times 1 over x. So once I know some basic ideas about logs and exponential functions, then I can figure out derivatives of logs and exponential functions using any base. What I would like you to do is try to find derivatives of these functions which have different bases from our standard e.